Your PS in or the input signal power given by this. The voltage signal that your antenna receive, okay, and you have the resistance there at the antenna as the input impedance. So what is the answer? Do we get the answer in watt? Can you please calculate that? Any question? Any answer for that? (45) times 10 power of minus 6 squared divided by 80. Betul dapat jawapan tu. 2.531 times 10 power of minus 11 watt. Did you manage to get the answer? Anybody?
Oh, dapat.
Huh?
Dapat.
Dapat? So you see this question didn't give you directly the value of the input signal power. Okay, so you have to calculate from the given parameters which are related to the input part of the system. So here basically the input is from your antenna lah. Okay, this is your input part and this part will be your output. So you have to be careful, okay, on reading the parameters that has been given to you based on the related question. Okay, so the overall gain in dB. So we have the overall gain and it's 1 in dB. So how many parameters that we have? The loss and also the gain. The loss from the cable, the gain from the RF amplifier, loss at the mixer part, and gain at the IF amplifier. So you need to add all those loss and gain, okay, to get the overall gain for the whole system. Okay, the loss at the cable plus the gain amplifier 1 plus the mixer, and you have again gain at the second amplifier. So basically when we said it is a loss, then you will have a negative sign. It's around 35. Okay, then the next question asks you about the output power. Okay, PS out in watt. So what you need to do is this, from this overall gain that you get in part B just now. Okay, that one is in dB. Okay, so you have to change that to the absolute ratio. Okay, then only we can use that value, okay, to multiply with this input power in watt that we have in part A just now. Okay, so how to convert from this to absolute ratio? Okay, so the overall gain just now is 35 dB. So to convert to the absolute ratio, use the anti-lock. How much you get the gain? It's about 3162. Okay, so you can use this. So 3162.3, the overall gain in the absolute value. Okay, then use that value So what is the output power? The signal output power? Betul ke? Any of you get a different answer?
Oh, betul.
Hmm?
Dapat sama.
Sama ke tak sama? So did you manage to convert the overall gain in dB to the absolute value?
Yes, betul.
Okay. So dapat jawapan yang sama, 3162.
3-1 situ ya.
Yes. Okay, so either you discard that 0.3, then mungkin you akan dapat jawapan lain sikit lah. 2.6, 2.531 tu. But overall dia akan dapat in this range lah. Okay, so the input noise power. This one, yeah, you need to use the given Boltzmann constant. Okay, so the given Boltzmann constant K tu 1.38 times 10 to the power of minus 23. Okay, that one has been given, but the temperature value is not stated right in the equation. So you can assume that the temperature is given, for example, based on your assumption lah, is 27 degrees Celsius. So to be used in this formula, okay, the temperature need to be converted to the Kelvin value. So it would be plus so that would be the value of the temperature that will be used lah. Okay.
Madam, sorry, madam.
Yes.
Is it a must to be in Kelvin?
Yeah.
Okay.
It should be in the Kelvin. So if you are using this noise power, then the value of the temperature should be in Kelvin. Okay, so the Boltzmann constant is given K. The bandwidth is also given in the equation. Okay. So the Boltzmann 1.38 times 10 power of minus 23. The bandwidth just now is given 20 megahertz. Okay, so what will you get for this? Okay, so the value in watt, 8.28. And then the last question asks about the overall noise factor, FT, of the system. So how to calculate the noise factor for the system? You have to use this, the freeze formula that has been introduced to you in this noise analysis calculation. So from where you will get all of those value, F1, F2, F3, and F4? Okay, all the noise figure value that has been given in the equation. So this one, 1, 2, 3, and 4. So you have to convert all those dB value to the absolute value. So the first one is 15, right? So get the absolute value. F2, 7 dB. F3, 8 dB. And the last one, F4, is 12. To get the absolute value for each of that. And then we go for the L1, the loss, -5. And then second one is the gain, 20 dB. Okay, so what is the value for F1?
31.62.
31.62. F2,
5.01.
6.3. Okay, did you manage to get all the value? Then only we can calculate the overall noise factor FT using that formula. Just plug in the value that we have for F1, F2, so what's the answer? Thailand, can you follow?
Yes, madam. Can madam?
So what was the answer for the overall noise factor? Dapat apa Sailan?
Uh, 49.18, madam.
49.18.
18.
Ashraf, you get the same value?
Dapat madam.
Dapat? The same answer.
Yes.
Okay. Okay, so this kind of question basically you need to be careful lah, because it is a dependence question. Okay, from part A, B, C, D, E tu is really related to each other. Okay, so once you calculate wrongly for any of the section, and then that value will be used for the next question, then the whole um, question for the whole system will be wrong. Okay, so you need to be careful with this kind of question. Okay, so that is on the overall noise factor. So this question also can be further ask you to evaluate on the overall noise figure. So what is overall noise figure? Okay, so you already have the overall noise factor FT here in absolute value. So the overall noise figure of the system should be in dB. Okay, so what you can do is just 10 log your FT just now. So we'll get the value in dB. It's about 16.92 dB. Right, cool. Convert the okay, the value in absolute value. Okay, so the noise figure and noise factor is basically related to each other. Okay, so the noise factor is in absolute value, and noise figure will be the value of that noise factor in dB. Okay, so some other related question about the noise temperature. You remember this, the noise temperature? Okay, so the noise temperature basically is given by this. Okay, where your F here is your FT, the total power for the system. Okay, so since it asks on the noise temperature of the receiver part, which means that the whole receiver system. Okay, so the T here, the one that we use in the previous question, 300. Okay, we assume that it is in 27 degrees Celsius. So this one also need to convert to Kelvin. Okay, since the noise temperature will be in the Kelvin value. So the F here is the one that you get from here, 49.18. So calculate that value, then you will get the temperature, the noise temperature in Kelvin. It's quite a very high uh, noise temperature for that receiver. Okay, and then we can also calculate the signal to noise ratio. Okay, for the this receiver system. Okay, so for example, our input SNR value, okay, the SNR in is given by PS in. We have the value of this signal power and also the noise power, right? The one that we have calculated before. So the input signal power and also the input noise power from the part A and part D. So PS in just now, what's the value? 2.531. Eight point eight. Both of them in watt. So get the ratio, and then we can calculate that value in dB. So you will get about 24.85 dB. So it depends on the decimal value that you choose for the given question. So try to be consistent, either if you choose 2 or 3, okay, decimal value, okay, for all the question, so that your answer will be synchronized lah accordingly. Okay, that would be the input signal to noise ratio. Okay, calculate in absolute value and also in the decibel in dB. And the last part would be the SNR out. This one also can be calculated in dB. So how to calculate this? The SNR out is basically based on this, the value of the input signal to noise ratio that you have minus your noise figure in dB. Okay, so you already have the value of this signal to noise ratio, the input signal to noise ratio just now, 20.85. The noise figure, seven point nine three. Okay, so if you compare the SNR out and also the SNR in for this system, is not really much lah. Okay, since you have the noise figure is also quite high, okay, for this system, so not much you will have for the SNR at the output part. Okay. So basically this one question is cover all on the noise analysis. So any question so far? Basically a lot of information that you can calculate, okay, based on the given receiver system. So in any of the system later on, the calculation or the evaluation will just be the same, okay, using the same formula model, or if any of the input power that will be calculated.